I would like to first remind you just very quickly about the office hours. So it's Monday, Tuesday, Thursday, 1:30 to 1:30 to 3:30. So the only office hours lab will be tomorrow. But if you really need some help on the lab, please feel free to drop me an email. I might be able to make some time on Friday, but you gotta let me know. Okay? But for now, I'm gonna take questions for the lab. I'll take maybe up to 10 or 15 minutes. Feel free to ask so I can address them to everybody. Okay? So go ahead first. Yes, the office hour, yeah. You can still come on Monday. Yeah. Yes. Just remind me again what the question is. So, yeah. Yes, remember. Okay, so now, question number 1. It's about what can you refer to in the precondition. Okay, I'll just talk about it very quickly. So, in general, in IFO, if you have any feature, let's say, for example, I'll just say valid index. Let's make it very specific to your lab number 1, so it's kind of going to help. Let's say you got class array container. That's your class. And remember, we said that we have a special section over there, and we say exported to none. Over there, that means everything you declare under this section here will be private. We'll talk about maybe next week to say why you want to do certain things. So there is a very sound software engineering principle. I'll just mention that now. It's called information hiding, which is a very important learning outcome from this course. I'll illustrate that next week. Okay, but I'll just mention that name. Information hiding. We're hiding something from the clients. But for this case here, we say that we got implementation over here, and we have array of string. So that's private. Only the current class array container can get access to it. And then we got another feature, let's say. Let's say we talk about queries. Let's say we have a feature called getAt. And then over here we have I being an integer, or should say int. And then it's going to return a string. And the question basically is, what should we do for the require, right? For example, so here require, let's think about the idea. We know that if you want to get something at a list or an array, the index better be valid, which means it should be starting from 1 up to including the size of the linear container, right? That's what we know. So maybe you will try to say, depending on the current size of the implementation, you might say, I should be less than or equal to imp.count. Yes, of course. Thank you so much. You should have told me earlier. Guys, thank you. You should really be a little bit more responsive. Yeah. Good. Good. Okay, that's one possibility here. So now, however, if you try that, I'm pretty sure many of you try, you wouldn't compile. You can read the reason a little bit more clearly from IFO Studio. But basically, the idea is we are violating the information hiding principle. Why? Why did we declare this imp as none? That means we want nobody to see it. But now, if you can compile this line here, what does that mean? That means anyone who can see the contract view of your class, who can see your contract view? The clients. Whoever can see the client, the contract view, they can see you got implementation account. In this case, what's the point of hiding it? Right? You got some conflicting ideas here. So here's the rule. The rule is, in the precondition, you are not allowed to refer to private features. In this case, imp is private because you can see that it's over here, right? We'll talk a little bit more about information hiding, but I just want to tell you very quickly why it is the case. We really intend to hide implementation, imp, but now we are exposing it again. So the conflicting ideas. Now the question is, how do you fix it? Well, there are different ways you can fix it. I'll give you some hints. There are different ways that you can talk about the size of the linear container, right? Remember, there is a feature in the linear container which will also tell you about its size. right? Use that feature instead. That's possible. Okay, that's my hints. Or you might find that you have to write this kind of precondition very often. You're gonna say it's between certain lower bound and certain upper bounds. If you're repeating certain code, as I said before, that means your code smells. In that case, why don't you factor this kind of expression out into somewhere else? In Java, you call this kind of thing helper method. Why don't you do that, and then you can call that helper method, which itself is public. Okay, so you got two possible fixes. Either you just refer to the feature in the linear container that talks about the size of the container, rather than imp.count, fix number one, or even better, you can try to factor out the common precondition into a particular helper method, let's say helper query. That's what you can do. Okay, I hope that helps. Good. Okay, next question, I know. Yes, guys, remind me one by one.
Okay, but I have one more question. So when we delete something in ifall, do we have something like in Java we had the garbage collection to?
Yes. So the question was, do we have garbage collection in ifall? Yes, we do. So in ifall, it's pretty much similar to Java. You cannot do any pointer arithmetic. You cannot say, I want to allocate a certain portion of memory of this size, and I'm going to free it. No, you don't do that. You do have garbage collection. Yeah. Yeah, okay. Guys, let me just talk very quickly about some idea about the contracts. I think for lab number one, preconditions are straightforward. I'm pretty sure you agree. The tricky bit is really about how to write post-condition. So because most of the time you will be the supplier, I want you to be clear about what might go wrong. And if anything goes wrong, one of the post-condition is going to catch that. Okay? Let me just go back. Let me just give you some idea. I'm going to draw some picture rather than writing ifall code, because that will be your job. Okay, let me just talk about a slightly different feature over here. In the instruction there, I talk about assign at in detail. Let me talk about another one. Let me talk about maybe two. First of all, what about, again, get at? And then we have I, and then we have integer, and then it's going to return a string. Okay, and then we have something over here, okay, something over here. I'm going to leave it blank just for now. And then for ensure, you have a bunch of post condition you're going to write. One of them is called, is it called nothing changed or something like that, right? Unchanged, okay. I'll just say unchanged. Yeah, I'll just say unchanged for now. You can look up the correct tag. Let me tell you what this is supposed to assert. Okay, let's draw some picture over here. Imagine that this is the linear container you're talking about. And we have A, I have B, I have C. Okay? And then this is the current one. And then I'm now given this linear container here. Let me just give a name. Let's say array container. If I say ac.get, get at, ac.get at, and then I pass index 2. Okay? I know that it is going to give me string B. One of the post conditions is going to assert this to make sure whatever that's returned as the result is really at that index that we specify. That's one post condition. However, why do we need another post condition called unchanged? Let me show you why. Let's see what might go wrong. In ifall or in any other language, although we call this feature a query because it returns something, it's a query. However, there will be nothing that will stop from any query or accessor in Java to somehow do some malicious change. Let me illustrate that to you. For example, let's say you do certain things over here that's correct. Let me say I'll do one more thing. What about I say I always say the implementation at position I minus 1 is assigned to bad, for example. It might happen because you're not a supplier. You cannot control over them. All you can do is to sign some contract which will constrain their behavior. Now, let's say I only have some contract to say if I try to get the element at position 2, I will indeed get B. But let's say there's a side effects for this particular supplier's feature. They will also try to change, let's say, This is the new linear container over there. So we still have B here. We still have C here. However, according to this, it's going to assign this to bad. So this is the old version. This is the new version, right? So far so good? So now let's talk about the two contracts. The first contract will say the result is equal to B. That's fine. This one is okay. However, you can see there's something wrong over here because by asking the result of this query, we at the same time also change the original array, which is not supposed to be the case. So now how can we catch that? That's why we need another contract, which is to say now since you declare yourself to be a query because you return something, so it better be that the old version of the linear container or array container is exactly the same as the new one. If you can somehow make such contract as a post condition, then this can throw some contract violation, which will report something, right? That's our intention. Let me just say one more thing. So this is very similar to, remember, when I illustrated how we can throw the post condition, I kind of changed the withdraw to say, I will simply say withdraw maybe minus minus, just do some additional reduction or something like that. Then with some wrong implementation, it can be caught by the post condition, right? So that's kind of the same idea. So when you are trying to do the features I asked you to do, you should really do different kind of tests. Let me just mention that before I take the next question. Okay. So there's different kinds of tests you should really do. And I will review the ESTest library very quickly today as well, just to make sure everybody is okay. Okay, there are basically kinds of tests you should write. The first one is you simply just compare expected value against the actual value. For example, let's say if I'm given a linear container over here, if I given, let's say, A, B, C, and D. Now if I say insert at position 2, and then I want to insert, let's say, E. In this case, I want to make sure once I'm done with that, I do have, let's say, A, B, and then I have, 1, 2, yeah, sorry, that's E, beg your pardon. A, E. E here, and then we have B, and we have C, and we have D. In this case, you just make sure you really have the same layout, what the expected layout of your array. Okay, that's kind of the first kind. And the second kind is you really try to test to fail. And there are two cases here. Maybe you intend to really have some precondition violation. Very simple case. Let's say if this is array container, I might say I'm trying to say AC dot get at, and then I'm going to say 5. Apparently 5 is not a valid index in this case, right? Because the maximum index you may get will be up to 4. But now you're trying 5. So now what should be the correct behavior of your program? You should throw the precondition violation. And as I will show you, to really test to fail, you have to use a slightly different test feature. Okay? So now to summarize very quickly, for number 1, you need some test query. For number 2 and also number 3, you need some test command. I'll illustrate it to you in iPhone Studio. And the third kind, this one's slightly trickier. The third one, you also want to test to fail. But how can you make the failure? In this case, you want to see the post-condition failure. For the second kind, if you want to test to fail just for the precondition, it's easy. Just give some illegal input value. But what about test to fail for the supplier? You have to somehow modify the corresponding feature, right? So let's say you're trying to do insert at. Again, you say 2 and then E, for example. And for the insert at, you got 3 different post conditions there. Let's say the first one. The first one simply say the count should be changed. Then you should really have one version of your implementation where the count does not change, let's say. If you implement the count as an attribute, you're supposed to increment that, right? But let's say you don't. If you don't, apparently the implementation is wrong. You should have a test case where it can cause the post-condition violation. Okay? So for every kind of post-condition violation, you're supposed to test to see if the post-condition will really be thrown. Okay? And that's exactly what I would do to test your code, to make sure you really did do it. So if you really don't do any test, you simply assume whatever you write is going to be correct. Don't gamble too much. I would say it's kind of tricky. You better test. If you're done with your features, but you're not too sure how you can test, feel free to drop by. I will show you more. But here, just the principle. Okay. Yeah, next question, please.
Will we have access to any more test cases?
I would say for this one here, let me hold it for now. I wouldn't say I will not for sure, but my intention is, since this is your very first lab and writing test cases is quite critical for this course, I would rather you guys try to write some test cases for now. Okay? I might give you some test cases as an example, maybe on Monday, maybe just for one particular feature. I would expect you to do the same for others, but let me not try to commit for now. I would say try your best, write your test cases. If you really got trouble, you still got time to ask me tomorrow or just by email. I'll say no for now. Okay. Yeah. Because I know in 2030, they were actually given all the test cases, which means before you submit, you already know if you got 100%. It's not fun, right? You'd rather be so confident with yourself, since I got so complete set of test cases and I passed all of them, I should get 100%. And sometimes when you really only get 90, then you should really try to learn from there. Why did I miss that 10%, right? But anyway, I'll try to give you some guys more hints, maybe on Monday, but I'll say no for now. Any more questions on the lab before I move on? No? Yes?
For example, I declare a local variable. I want to ensure it reach a certain condition.
Okay, so the question was how you can write contracts about local variable. Let me clarify the concept. Similar. It's a little bit like, can we refer to private attributes in the precondition, right? So now, you certainly cannot refer to local variable because they are hidden. Local variable is supposed to be hidden from the rest of the world. It's only local to the routine, to the feature. So I can give you one example. So let's say you have maybe integer I, just make it one example, integer I. And you have your implementation here. Let's say somewhere down the line, you would like to somehow to make sure I really reach certain states. Yes, you can do that. So there's something called check, which we do for the ESTest. You can say check, for example, I at this point is larger than 0, end. Just check, end, and with some Boolean condition, you can do that. And somehow this is not contract, it's just assertion. Yeah, it's hidden. Okay. Yes?
So say you assign result to something called a Boolean.
And I said check result end.
Yes. So is that required if it's a Boolean?
I will mention that, yes. Yeah, that will be my first topic today. Yeah, I'll talk about it, yes. Questions? Any more questions about the lab? So hopefully you're enjoying it, right? It's kind of interesting to write a post condition, I hope. But anyway, we'll try. Okay. You know what I originally planned? I actually thought about to give you guys two versions of the linear container. One by array, the other one by linked list. But I ran out of time writing the instructions, so I give you only array. But anyway, I'll save that for later. Okay, so now I want to just go back to writing tests very quickly, and especially go back to the result and test query and test command, etc. Without going through the slide, you can certainly read the slides yourself. I'll just mention the idea when I'm doing some example in EStudio. Okay, let me just go to this project over here. Okay, I think it's better font, it's not too huge. So what I'm going to do is I'm going to reproduce more or less the example you did in the slides. Okay, let me just review what we have. We have a bank and we have account. Account, we have owner, we have balance, and also we have one single constructor. And the balance has to be larger than or equal to 0. And also we got withdrawal. Okay? So now, I want to demonstrate to you different points over here. let's see how we can test to succeed. Okay, how we can compare the expected value with the actual value. So now let's say I have one test over here. So you know how to create a test classes. I just skip that step over here. Make sure every time you got a test class, it has to inherit from ESTest. Okay, let me now declare the constructor here. I'll say make. That's just the convention. So now you can say constructor for adding tests. And then we can say make over here. So every time you have a new test, you can add it to there. And there are two kinds of tests. Not Java. Two kinds of tests you can add. Okay, I will explain each one of them in just a moment. So now I'm going to use the feature clause over here to group different test features. So here I'm going to say test queries, in which case we are trying to test to succeed. The next section there, which I will do second, is test commands, in which case we test to fail. Okay? The test query is a little bit easier. We simply just try the normal cases and try to compare. And I will get to the check result end in just a moment. Okay? That's exactly the context where we have to worry about. Okay, so now the convention is we start with test. Let's say test, let's say withdraw. Test withdraw, just with a Boolean. So let me tell you the principle of what does it mean, what it means when you say a test query passes. First of all, I would say this is a test query because it has a return value. And in IFO, as I said in the slides, the way we do the return value in IFO is a little bit different from Java. You don't say return. You simply try to reassign a keyword called result. Whatever the final result would be, that will be the return value. So there's some implicit return, implicit. Okay. Okay, let me just, and always don't forget, you must put a comment here. Put a comment here, and then you can say test withdraw. Okay. Example. Okay, it compiles. So now let's see how we can do that. First of all, let me do this one first. Let's say do a local variable here because we are trying to test. We are being a client. Local ACC account. So now let's say ACC dot creates account ACC dot make. And then let's say Alan, let's say 100. So far so good, it's just valid. Okay, compiles. Let's now, this is a normal scenario, and every time after certain normal usage, you would like to see if I really have done the right thing. So what do I want to say? After this, we want to know if Alan has got 100 initial balance. Okay, the way to do that is we can say result is assigned to ACC dot balance is a Boolean expression, and that should be equal to 100. Okay, let's do that first. And let's say we try to run this. What's going to happen? If you try that, you can simply say, oh, let me just also, remember we also got test suite, right? You can also inherit from test suite. You can just go over the slides. I explain everything in the slides. So what's the difference between, let me just clarify this very quickly on the notes. Okay, so now let me just add a new page over here. Don't be too confused. The idea is not too bad, not too difficult. So we have something called ESTest. We also got ES suite. Okay, so for ESTest, it's for you to add test cases. And also, each test case should correspond to a particular scenario. correspond to a scenario. And over here, you can either test to succeed or test to fail. Or to fail. And also, there's also one thing that's quite important. Usually, you will create, that's why we call it a unit test. You only do, so each ES test should focus on testing a single class. For example, we have one class called test account. Let's say later on we have another class called bank. Then we'll create another class called test bank. Just have the one-to-one correspondence. Okay, what about suite? Suite basically simply collects collection of ES tests. That's the idea. So that's why it's called a suite. Just collect everything together. And whenever we run it, we run the whole thing. Okay. Let me just go back and then I'll show you. So over here you can see that for ES suite, so far we only got one ES test class, which is a test account. So what you gotta do is very simple. You just have to know which feature you gotta call. It's called add test. Okay, and now to add a test, you have to add an instance of ES test. So for this one here, let me just do a little bit detour for you first. You can say local, I'll say T, and then we have test account. That's what we just declared, right? You can create it, create test account t.make, and then you can pass T. Okay, that's one way to do it. One way to do it. But remember in Java, you talk about something called anonymous objects, which means there's an object without a name. Okay. Again, let me review that very quickly. Okay. Okay. Let's say over here. Okay, let's say in Java. In Java, you say account ACC is new account. That's what you say. So this object here has a name called ACC. How do you create anonymous objects? Let's say now, let's say I have a bank B dot add account, let's say hypothetically. So here you can either say I want to add ACC into it, or I can simply do this, add account. Now I can simply just do something like this. I can say new over here, account, right? And then you have some parameter over here. Okay, that's what you do in Java. You got something similar in iPhone as well. So what about in iPhone? Over here, if you have, let's say, you say create account, you say acc dot make. That's what you have. That one has a name, ACC. How do you create anonymous objects in iPhone? It's easy. Take out the name. What about anonymous? You can say create account and then dot make. Just that. So that's anonymous. Again, it's just syntax you gotta get used to. Okay, let's try this in the eStudio. Okay, let's try that. So now this is one way to do it. So I'm just going to comment this out so you can look at that a little bit later. Okay. Now I want to say create test account dot make, and that's it. You can see I don't really need to create some intermediate variable. I can just pass anonymous objects without a name. Okay, let's try to run it. You can say run workbench system, and that's what you'll get. Did I have that over here? Okay, let me just try again. Run workbench system. Did I change that? Let me just see. Make sure you have, do I have compile error? No, I don't. Let me just check something. So project settings, so test suite.make. Yeah, that's fine. Okay. If it doesn't come out, that's fine. Okay, why don't we just continue? Imagine that has come out and say green bar. Okay. So now let's go back to test account. I want to do a little bit more. Okay. So now, how can we do from here? Sometimes you may have more than one assertion in the test feature. And how can you do in this case? In this case, let's say after we have asserted that the account.balance is actually 100, we can do more. For example, we can say acc.withdraw. In this case, let's say 10. acc dot, okay, just do that. And then we can say result is assigned to acc dot balance is assigned to 90. Okay? So what's so good? So now, I can tell you that this is not good because you missed something here, but I'll tell you why you need it. Okay? Why do we need this? I'll tell you why. What will happen if you have without? Okay? Let's imagine some very peculiar implementation. Okay, I wouldn't do it. I'll just mention that to you. You can imagine very easily. Now imagine that acc.make always initialize balance as 90. Let's say, very weird implementation. It always does that. You pass 100, 90. You pass 1,000,000, 90. You pass 50, also 90. Always the case. It's wrong. And let's imagine also the withdraw is also wrong. Imagine that acc.withdraw always withdraw nothing. You tell it that I want to withdraw 1,000,000, withdraw nothing. Withdraw $10, withdraw nothing. It has no reduction on the balance. So we got double errors over here. Okay? Now I want to ask you something here. According to these two wrong implementation, which we got two reassignment here. We got this line here. We got this line here. Let's say call this number 1. This is number 2. Which one is going to assign result to be false? The first one, right? Because it's going to initialize that to be 90. 90 is not equal to 100. On the other hand, the second one is going to withdraw nothing from the 90 that was in the first place wrong. However, since we are trying to compare 90, right? So that means what's going to be the final value for result? True. Somehow the false in the intermediate level was overwritten, right? In this case, remember what I said before. For the test query to really pass as a success, as long as the result's final value is true, it will be considered as a success. In this case, it will be a success. But that's misleading because it should have been caught in the very first assertion. Make sense, maybe? Yeah? Okay. So now, this very first reassignment will change result to 90. Oh, sorry, just to 90. Change result to false. Okay. And then this second reassignment will change result to true again. And only the final value counts. So now what should we do? What we should do is we want to make sure every intermediate reassignment to result gives that true. That's what we want to make sure. Okay, so that's why we need this one here to really catch that. We need such an assertion at each intermediate point to make sure result never gets to false. Is never false. Okay, does it make sense? Okay, please run it. Run it through. Somehow the browser doesn't work on my computer at the moment. It worked before anyway, so I don't want to waste time playing with that. Okay, so please try that. Try if you simply comment this out. It's going to be considered a success. Otherwise, it's going to be a failure. You know why it didn't run? Because I didn't add it. I think now it will work. Okay. So if you want to add a test query, you will say add Boolean case agent test withdraw. We will talk about agent a little bit later in the course, but for now, understand it this way. You're trying to pass a pointer to this particular test query. Agent is how you take the address of a function, like what you learned in 2031. Okay, so now I'm pretty sure it's working, I hope. So now let's say we don't have this one here, and let's try to run it. Compile, run workbench system. Good, you see it passed. Why? Because we didn't have that intermediate check. It was commented out. However, if I comment that back over here, if I try that again, compile and run, it will catch that error, I think. Should I try again? Because I said imagine, I didn't really change it. You see, that's the problem of doing a live demo. Okay, now I will change it just for the illustration. Let me go back to account. Let's go to account here, and I'm just going to temporarily change it. Okay, let's say this is wrong, intentional. So I'll simply say balance is always 90, right, as I said before. Now for the withdrawal, this one is also going to be wrong. In this case, I'm going to say balance is assigned to, well, just no reduction. I'll just say, just make it explicit. Okay, that's kind of the wrong implementation I just imagined, right? Now it's really there. Let's try again. If I try that, it will be caught because the intermediate assertion there actually fell. Yes?
Won't it catch an ensure block inside the, in the withdraw method? You have to close condition.
In the withdrawal method, that's a good question there. But somehow I... So, right. It should have been caught. Let me try again. Let's try. If we have that, that's a good question there. Why don't we try very quickly? If you only have this, you're claiming that it should. It's a post-condition violation, yes. However, if I, just for the sake of clarity here, I'll just go back there because I really want to illustrate you just cannot have any intermediate value of the result being true or false, right? Being false. If I go account, in this case, if I simply just take this out just for now, okay? And then if we try again, oops, wrong. Now this one, let me test account. This is really what I want. Now I do have the intermediate check, right? Guys, I know it's a little bit tricky, yeah. All right, we do have to check assertion failure, okay. Anyway, my point is every time you're trying to have a test query, you got some intermediate assertion result, make sure check result end. That's important, okay. Now, second category, yes, please.
If you have a whole
Yeah. You don't know which one fell. Very good question. Let me just go from here, okay? Let's say we know that this one's gonna fail. Let's say we say run, and somehow you will see that your Eiffel Studio is gonna tell you that you have this particular check that has failed, right? So once you see that from the debugger, you will see, right? You can see over here, we know that the previous thing we just did was we're simply trying to assert balance is 100, but it failed because the result was false, right? That's how you find that. But you cannot put any tag, and that's how, not like for pre or post condition, no. Okay, very good. Okay, so now let's go back there, and then I'll show you how to do the second category of check. So somehow I don't see the stop button there, so I'll just close this, and then I'll do it again, okay? Okay. Okay, now I will show you just one, how you can test for precondition violation. Let's see how we can do that. Okay, so now let me just go back to my account class over here, and then I'm going to just remember, let's just test something very simple. Let's say one of your lab exercises was, if I'm trying to, let's say, get at a particular index, you might have some precondition violation, right? If the index is not valid. How do you test to fail? You give some invalid index and make sure you expect the expected result is really a precondition violation, right? So now how do we do that? Let's say something similar. Now we want to make sure this particular precondition with this particular tag is really going to be violated. How do we test to fail exactly that? So what we're gonna do is we're gonna call this make, and then we'll give something that's going to make this false. Let's say some negative balance. Okay, I'll show you how you can do that. So this one's a little bit more difficult to do. Okay, so let me just go back to test account over here. Okay, so now I'm gonna do that in under test command over here. But for now, I'm just going to comment this out just to isolate. Okay. Okay, so now let's do this. Let's say test illegal initial balance. Initial. So now we don't say Boolean anymore because we really don't want to compare any two values. We simply want to call a feature in an illegal way. We simply expect some contra violation to occur. So how do we do this? Okay, so we simply do a command, and then we say do, and then comments. Test to violates a precondition. Okay, so now again we're going to declare the variable to use it. So we can say ACC. Let's say ACC. Yeah, that's fine. Account creates account ACC dot make. Okay, and then I'm gonna pass some name over here. Alan. Let's say minus 100. And as far as the test feature is concerned, we are okay. We don't need to do anything else. Okay, I just add a comment here. We expect a precondition violation to occur. That's what we expect to see. If anything else that has occurred, then it's going to fail. Okay? How do we do that? So now we want to make sure we add this to the make feature, so it will be taken into consideration in the test suite. Let me copy this name over here. What you need over here, rather than add Boolean case, is something called add violation case. Add violation case with tag. So this is really what you want to write to test your software for lab number 1, because we got tags for every precondition, postcondition, right? So now, sorry about that. So now, let me leave the tag empty because I gotta look it up, because if the tag name is wrong, you're gonna get it wrong. So I'm gonna say agent, again, I'm gonna pass a pointer to this function here. So now let me see which tag exactly am I going to violate. I'm going to violate this one particularly, just copy and paste. Copy this tag here, go back there, And then I'm going to paste over here. So that means the ESpec test is going to run this command, which is going to make an illegal account with a -100 initial balance. So we expect some contract violation to occur. And that particular contract has this particular tag. That's what we are trying to assert. Okay? Let's try to see if that's really the case. Compile, and then run. Yes. Now, let me show you how careful you should be. Let's say you kind of forget. You put maybe dash rather than underscore. It's not going to work. It has to be exactly that tag. So that's why I told you guys, don't change the tag for the pre and post condition. Oh, wrong one. Workbench system, right? You see, because the tag was wrong. Okay, any question about test to fail for the precondition? Are we okay? Okay. And now, finally, just for completeness, let me talk about how you can fail for post condition, and then we are done for the test. And I'll go to the next topic. Okay. Make sure you have that. Okay. So now let's see this. At the moment, you can see that we have. Let's just test also something very easy. Let's say this is the make feature. We want to say the balance, initial balance is set. That's a tag. And then I want to say the balance should be equal to exactly the new balance, right? However, you can see that this balance here is wrong. You always set it to be 90. So what you really want to do is you can somehow tweak your implementation a little bit and to make sure you can test the post-condition failure. Okay? The way to do it, for example, here, I simply comment out the right implementation and put something that's wrong and to see if the corresponding post-condition will be violated. Okay? So now, I'm going to do that very quickly. Okay, I will say test. Again, for clarity, I'm going to also comment this out. Okay, so now I'm going to just have another one over here. I will say test wrong implementation. Wrong implementation of make. Okay, test to violate a post condition. So we expect a post condition violation to occur. So let's give something valid. So we wouldn't have the precondition violation, right? We want to have the post condition violation. So now we expect the new balance to be 100. However, the wrong implementation will give us 90, right? That's kind of the idea. So now let me just do that. So let me first of all copy the name of the feature. Let's just do another add violation case. Add violation case with tag. And then over here, we're going to have a tag. I'll do that in moments, and then agents and this. Okay, let's go back there to make sure we got a right tag. Initial balance set. I'll copy that, and then I'll put it here. Okay, you see it's different. If you want to test to fail a precondition, give some illegal input value. If you want to test to fail the post condition, you have to modify the implementation a bit temporarily, okay, to make sure everything just works. Okay, let's compile and run again. All right, we do have a post-condition violation. Okay. Okay, guys, I know it's a little bit fast, but if you got any concept that's not clear, please ask before I move on. Are we okay? Yes.
Can you create a test that loops over all possible conditions if it's like a
And what do you mean every condition? What do you mean?
Like, let's say you can go over every single negative positive number.
You mean for testing the precondition violation, or?
Just for testing in general.
You can write a loop, I suppose. Uh-huh. What do you mean exactly? I don't quite get your question, actually.
Let's say you have something that takes a certain number,
Yeah.
and then all it does is it adds one to it and returns.
I see what you mean. I see what you mean. I'll sketch the idea. The question was, can you somehow just write a single test feature, but somehow it cleverly does many things iteratively, right? I know what you mean. Let me just say that over here quickly. Okay, I think the one you just mentioned is a good example. Okay, do we have that? No. Disconnect, connect. Okay, that will be the question, and then we'll move on later. Okay, good. Okay, let me now say this. Let's say we want to test a very simple feature. Let's say the feature to test let's say a query, okay? Let's say add 2. Whatever integer I you give to it is going to return some integer. Okay? It's supposed to add 2 to it. So now how do we do that? Okay? Easy. So now let's say we do a test query. So you can say test, I'll make it a little bit more explicit. Test add 2 for 100 input. I'll make it explicit here. And then I'm going to say here, oh, sorry, that's not Java. And then I'm going to say Boolean. And then we have do, and we have end. I'm going to see a little bit of space, otherwise I'm going to run out. It's comment here. You can put the comments. Okay, let's say we test from 1 to 100, let's say. And also, I need to have some local variable. Local, I can say I is an integer. Okay, so I will be the input. I can say from, until, do, and end. Okay, so now I can say this. I'm going to use a different color. From I is assigned to 1 until I is larger than 100. So 1 to 100. Okay. Now I can say result. Somehow I'm trying to I don't need to accumulate. So let's say a result is simply assigned to add 2 of I is equal to 2 plus I. You see? Okay, it's a Boolean condition. It's a Boolean expression. And then I can say check result end. So basically, when I is 1, I'm going to check to see add 2 with 1 is going to be 2. It's going to be 1 plus 2. Add 2 with 2 is going to be 2 plus 2. Add 2 with 3 is going to be 2 plus 3. And the final input I will have is add 2 with 100. It's going to be 2 plus 100. I'm going to check every one of them. If any one of them fail, I'm going to have this check result end failed. Okay? Guys, do you see the point here? I think it's actually a very good question. So you can also try to be a little bit more clever about the test input you have, right, over here. Make sense to you? Okay, any questions before I move on? Okay, I just want to do a little bit more slides on classes and objects with some illustration. And then we'll start with something that's more interesting from Monday. Okay? And for the rest of the slides about TDD, please just finish that yourself. We basically cover everything already. So there's no point to just go read them through again. Okay, let me close that. Okay. Let me go over some slides about classes and objects. They're kind of easy concept. Let's just make sure we are on the same page. Can I skip that? All right. Always got some trouble. Cancel. You know what I will do? What I will do is I will show that over here. So, sorry, bear with me. So, slides. Okay, so it's 11. And then, okay, so what I really want is the classes and objects. However, not this version here, over here. Okay, that's the one. Okay, we'll see how far we can go. Just a few concepts over here. Okay, we're going to talk about classes and objects. So in your previous lectures, in previous classes, you always talk about Java. So I want to show you one diagram first. Why are we using object orientation, which is supported in both Java and iPhone? I want to show you this diagram over here, which is give you some rationale why things will work more intuitively if you do object orientation. It's a simple example over here. So there's 3 stages over here. The first stage, let's say here, we talk about real-world entities. So let's say you're trying to solve a problem. So typically when you're in the industry, what you're trying to solve should be something to do with people, with machines, with maybe 2-dimensional points. There's certain reality there you have to model, right? Certain problems. For example, in this case, let's say I observe I have Jim, I have Jonathan. They're kind of persons. They're like one kind of entities. So what do they share in common? They have names, they have they have names, they have weights, they have heights, they got some common attributes. And meanwhile, I got another kind of entities, which is 2-dimensional points. In this case, they got different attributes. They got X, they got Y, right? Different attributes. So now once you observe such reality, what would you do? What you will do is you will define them into classes, let's say in Java or in iPhone. Once you have done that, so you can do attribute over here, you can do attribute over here as well. You can also define the operation or methods that you can call upon the objects. Now what's really interesting is, once you define the classes, when you instantiate them as objects at the runtime, the way they work or the way they interact with each other will certainly correspond to what happened in the real world. Let's say here, you can see Jim is actually a point to a person object, and then we have name, we have weight, we have height. It has certain values for them, right? It's how you visualize an object. Similarly, let's say we have just another instance of person. Since they are the same kind of instance, so you also have name, weight, and height, the same. However, the attribute values may not be the same, right? So that's kind of the idea, right? So we got 3 stages over here, okay? That's about object orientation. And now let me go back. Okay, let me just go over some concept about here. Good. Okay, first of all, let's talk about abstract data type. So that's something a little bit more mathematical, but let's try to see. So what is an abstract data type, ADT? So let me show you just another diagram, which will also complement this. So now ADT. Okay, this is a diagram I would like to show you. I'm not sure what about the green line over here, but let's pretend it's not there. Abstract data type. This is how we understand every problem you're trying to solve. Let's say for lab number 1, we have a container. In this case, we choose a data structure to implement a container using an array, right? And then you actually have some interface, which is public. That's how you interact with the outside world. In this case, you have insert add, you have get add, you have valid index, etc. Okay? And then, so this is the supplier part, and that's the client part, so ADT. Okay? So now, next week, we're going to talk about something that's very fundamental. Let me just go back here. Okay. At a page below. Okay, let me just draw a box over here. Let's say this is your linear container. In this case, let's say we're going to support several features. Let me just put 2 for now. So you might insert add, you might get add. So these are the public features, right? Inside, so it's like a black box. Whatever that's inside the box is hidden from the outside. So let's say here, let's say for the moment, I'm trying to do implementation and then I will say array. I'll just say array for now. Okay, So now, let's think about how clients are going to interact with us. Let's say there's some client over here. Okay? So now, what they will see are only the public features. So whenever they're trying to write some code, they will never write the code in terms of the implementation, right? Because it's hidden from them. So that means we can safely replace, let's say later on we decide array is not a good idea. We might do implementation, and then we have linked list. We can simply change our implementation strategy internally. Whenever we do such change, it better not affect the clients because they don't care what we use, right? It's some strategy called information hiding. So I will show you some concrete code next time, just to see how information hiding can be put in IFO and other languages. Okay, that's why we need private features. Okay, good. And to go through something here. Okay, so we have object. So object is simply an instance of a class, and class is an abstract data type. But what's abstract data type? We'll see that. Okay, so this is kind of inheritance hierarchy, a partial view of what's happening in IFO. Remember in Java, you have the superclass of every class called objects. In IFO, they call it any. Okay, just the correspondence to show you. It's any. Okay, you might see that. Maybe we might see that a little bit later. So now, Java interfaces are not abstract data types. Why? Let me just go back to the definition for abstract data type, which do I? Okay, good. Okay. For abstract data type, we got operation, which is like methods. We also have properties. So these are the things that you cannot really do in Java. I'll give you one example. It's more mathematical property. So this one, you can see that from the textbook over here. Okay, let's try to read it together. So over here, we say that we have an abstract data type called stack. Okay, for the stack, we are trying to support different functionalities. So over here, we say that we have a put. As you learned from today's lab, put simply means you want to push, well, just like a push, basically. You want to push something to the top, and then you can remove, you can do item, you can do empty. One thing you will see, you can see it's like a mathematical function that you learned from 1090, right? You can see the argument there, the first one is always a stack. Okay, that's how we define things mathematically. I will give you one example. So let's see, we got put, remove. Okay. I don't think I need IFO Studio anymore, so I can close that. And then I'm going to have a new page. Okay, so we talk about abstract data type. So we have operations. Let's say we have a stack of certain things. So that's something called generic parameter. And you have seen that already. For example, in today's lab, you saw something like array of string. Oh, again? Oh, that line there, right? I'm actually, to be honest, I'm not too sure why that line is there. Would it work if I simply try to do that? Okay. Okay. Okay, generic parameter. So now, let's think about what's the idea about generic parameter to begin with. When you are trying to store something into the array, what we learned from Java, the only constraint is every element in the array must have the same type. It can be an array of person, it can be an array of string, it can be an array of integer, right? As long as they're of the same type. We might have an array of person, and we might have an array of, let's say one more, integer. And now you can see that over here, these are all instances of the types that you can give to the elements. You can give to string, person, or integer, or any known class that you can give. However, when we try to define the array class, we don't need to give different versions for this kind of array. So for example, we don't need to create a separate class for an array of string. We don't need to create a separate class for an array of person, etc. We only need one particular class, which is called an array of G. Okay, array of G, and this is called generic class. And this is also something I will talk about, okay, just as a preview, okay, generic class, which means we factorize the type for every element into a particular thing, and we can instantiate that into different, either string or person or integer. Okay, let's go back to ADT. I just want to give you some small example, and then we're done. Okay, I think it's good to just pause over here. Let me just talk about ADT very quickly. I'm going to give you one example here. If you look at the slides over here, okay, you will see that I want to just get some property here. Can we just have a quick look? Let's see over there, A1. Let's try to understand that. Item put is equal to X. Okay, item and put. Okay, so I'm going to make some example to you. And then let's try to understand that small example. And then, okay, I'm going to, good. So now let's define two operations for stack. So now let's, first of all, we have put. So put, let's try to define that mathematically, which means put is going to, given a stack, and then let's say stack of integer. And then you are trying to give another integer, what you will return is just an updated stack. Okay, and then we also have something like this. We also have something called empty, which will give you an empty stack. That's one more. We also have item over here, which is going to give you to say once you got a stack, integer, and then you want to pop. In this case, it will just give you an integer. Okay, something like that. Let's say we got three operations here. So now, once you specify these three operations, in some way you want to contract to see how these features are supposed to work together. Okay. For example, over here, let's say this. If I have, I think I just need one more, remove, which is like a pop. If I say remove, I have one stack given, and then I will simply just give to you, oh, actually the same. No, item is like a peak, sorry. Item is like the peak method. And then this is like a pop. Okay, and then just give you another stack. For this one here, just give you another stack that has the top being popped. Okay, let's just see one property over here. Okay, one more page over here. Okay, one property. Let's state that in English first. So we are trying to constrain the way the stack should behave. We'd say after pushing, let's use the 2011 term you are used to. After pushing an item X into the stack, and immediate pop will give to you X. It seems obvious to you, right? No? Let's say I have already got this many contents in my stack. Now I'm trying to push X into it. immediately follow that, I'm trying to pop, what would I get? X. So that's one very simple property for the stack. And that actually tests that in some way this involves two features. So it involves pushing and popping. Okay, let me just state that mathematically very quickly. And then I'll make a conclusion and we are done. So now first of all, if you're trying to push is a function which will take a stack and then some element x, mathematically speaking. Okay, in object-oriented notation, it's going to be s.push, right? And then x, but it's different. Now we talk about math. So this one over here is simply a new stack with x on top, basically, right? If you look at the mathematical definition. Now what we can do is, let's take this stack and then we'll try to do pop. Okay? In this case, we are trying to pop a stack where this particular stack just did a push of x. So what will we get? Wow, x. So what's really useful, well, of course, this is a very simple example. What's really useful of thinking about this kind of mathematical property? Well, you can write test cases about it, right? You can do, rather than just testing your push, you can say, I'll push and pop. If I didn't get back the same elements, I'm in trouble. There should be some kind of contra violation. Okay? So absent data type, I will come back here a little bit more, especially when we talk about information hiding. Okay? Okay, how about we finish earlier today? Good. So one more thing. If you got any more questions about the lab, so I do have office hour tomorrow. If you need more time, feel free to drop me an email. We can make some time on Friday. Okay?